Good morning, everyone. I hope you had a great weekend. We're going to go ahead and we're going to take a look at your homework from last week. We're just going to go through it real quick. I've been trying to keep up with grading it through assessments. Hopefully that's working out for you. Hopefully you're able to get on that. I am noticing some students that are using multiple variables to write your expressions. You cannot do that. You cannot do that because how are you going to solve it? Okay, so right now you only want one variable and then base your other expressions around that variable. Okay, so let's go ahead and go through these answers quickly. A number decreased by 3 squared. If you had written 9, it would have counted right. Okay, and that was linear because the exponent with the x is 1 with your variable. Okay, the quotient of 2 and a number, so that's 2 over x subtracted from 17. So that's subtracted from 17. It's nonlinear because that exponent is -1 because that x is in the denominator. All right, again, stop wherever you need more time to look at these. You are responsible for these. So if you are choosing not to learn this material or skipping through this material, then you're not going to show proficiency in this module and you will not go on to algebra. Okay, so you still have to show proficiency, so you still got to learn this stuff. All right. Okay, there's 4. There's this one. Okay, half the tickets were sold on Tuesday. And then the rest on, so definitely you could have combined these to do 49 plus 1/2 x, and that would have been great. All right. So now the exponent is 4, not 1. Okay, because you have to distribute that because it's in parentheses. All right, again, as long as that x has an exponent of 1, it is linear. You will be able to create a straight line if you were to graph it. All right, there's 8, 9, 10. Go ahead and look at those. So these are just coming straight out of your Eureka book. This is exactly what I would be giving you if we were in the regular classroom together. Okay, go ahead and email me with any questions you may have. If you have no questions, we're moving on. And here we go. All right, let's go ahead and take a look. We want to define linear equation in x. So again, if we were to graph a linear equation in x, we would make a straight line on the graph. All right, so here are some examples of linear equations right here. Shh! Trying to teach. All right, so if you were to simplify any of these, then or combine like terms, then you would find that the exponent on that variable is going to be a 1. All right, so if we look at these, let's go through and check, make sure these are right. 4 plus 1, yep, that's right. This one is not correct. That one is not correct. There we go. 21 minus 6, yep. And 6 minus 2, no. So those are not correct. And how do we know they're the correct? Because the values on the right side are equal to the values on the left side. All right. That's might be very easy for you right now, but it makes sense when we're solving these equations in x as well. Okay. So let's try this. Is 4 plus 15x, got my Michael Jackson glove on, is 4 plus 15x equal to 49? Well, let's go ahead and we're going to solve for x. Alrighty. You know I have my Michael Jackson glove on, because when I rest, my hand on the screen, it doesn't create any kind of marks. All right, so we're going to go ahead and get rid of that 4. And then we're going to divide by 15. So x is equal to 3. So the answer to this question is, yeah, that's true. Only when x is equal to 3. Okay. So yes, when x is equal to 3. And that's a fallacy. Let's look at the next one. Okay, so when we define linear equation in X, it's a statement of equality where you can find all solutions for X if they exist. And that's what we're leading to. That's what our ultimate goal is, to find all the solutions for X if they exist. Okay, so let's continue. Let's practice. So if we look at example 1, it's the same example that we already did. So is there a number x that makes the linear expression equal to the linear expression 49? Yeah, we already did that one, right? And we found out that that number was 3. All right, let's try the next one. Example 2. Is 5 a solution to the equation? So all we want to do here is substitute the 5 for the x's. So every time you see an x, you're going to put a 5 and then see if the both sides are equal, if the right equals the left. So I'm going to put you down here, and we're going to try it. 8. And we'll change that. Since we're substituting that, we'll put our 5 in there. We'll go back to blue. Equals -4 minus 7 times 5. All right, so let's go ahead and solve this to see if both sides are equal. So I have 40 minus 19. Is that equal to a -4 plus -7 times 5? Notice there I just changed it to addition. Why? Because I can, and it makes it easier. Okay. Hi, Nemo. Hi, baby. All right, so 40 minus 19 is 21, equals -4 plus -35. When we have two negatives and we're adding them, same signs, add and keep. So 21 equals -39. Is that true? That is not true. So no. Okay, why? Because the right side does not equal the left side. Moving along. Whoa. Let's look at the next one. Now, the only thing different here is we have a fraction. So you can go ahead and stop it if you want. If not, you can do the problem along with me. So 3 times 5/4. Whoops. The parentheses in the wrong place there. Plus 9. I won't change my colors this time. Lots of gobbledygook here. All right, so let's just do what's in parentheses first. So 9 plus 5/4, that's really 1 and 1/4, right? So we'll say 10 and 1/4. Is that equal to 5 minus 7 plus 35/4? We'll see how that goes in a second. So 3 times 10 and 1/4 would be 30 and 3/4. Is that equal to 5 plus a -7 plus, let's go ahead and we'll put that into It's number form, so 4 goes into 35. Let's see, 9 would be too many, so we're going to go 8 and 3/4. Now we're crunching on example 4. Oh well. 30 and 3/4, 3 4s. So that's a -2 plus 8 and 3/4 is 30 and 3/4 equal to 6 and 3/4. All right, so you want to go ahead and check that. And no, that is not correct. No. So if you left it as number 1, an improper fraction, that would have been fine. You would have still been able to tell the equality or the inequality, and decimal as well is fine. Okay. All right, example 4. Is 6 the solution? So go ahead and stop the recording if you haven't already and figure it out, then come on back. Okay, so hopefully you were able to get -33 equals -31 equals -31. So yes, 6 is a solution to that equation. Okay. Can you combine like terms and actually solve for x? Yes, we're just trying the substitution method right now, but then that's exactly where we're going. All right, here we go, on your own. So that means stop the recording and do it on your own. Don't forget to come back, y'all, you hear? Okie doke. So yes, that -3 is a solution to that equation. You notice in my first step here, I combined my x's, and I automatically said 5x plus 2x was 7 times x, which was 7 times -3. Because it makes more sense to me. It requires less steps. So that is absolutely fine if you want to combine those like terms and then solve. Okay, number 2, stop the recording and try it. And don't forget to come back. And I'm back. So yes, the right side equals the left side. So 12 does satisfy the equation, we can say, or x equals 12, right? Okay. But a lot of times in your homework, you'll see this word. Does 12 satisfy the equation? That means does it work? And will the right side equal the left side of the equation? All right, our ultimate goal. Perfect. If you did get this wrong, my guess is you either made a minor calculation error or you're not using your order of operations correctly. Okay, PEMDAS, parentheses, exponents, multiplication. All right, on and on. You know the rest. Oops. Now you see it, now you don't. Okay, so let's go ahead and try number 3. Chad solved the equation, and you're going to go see. He claims that 2 makes the equation true, and you're going to look at that and correct his. And then let's go ahead and see if we can squeeze the next one in. There we go. Lisa solved that equation. X plus 6 equals 8 plus 7x, and claimed that the solution is x equals -1/3. Is she correct? So go ahead and do those 2 problems, and then we'll call it a day. Alrighty, so for this one about Chad, so 56 does not equal 57, and notice what I did here. That's a does not equal sign. Okay. Your standard explanation can always be the right side does not equal the left side, or if it is a solution, the right side equals the left side. Okay, so that's what you're looking for. And then the very last one. And yes, the right side equals left side. Okay, 5 2/3 equals 5 2/3. Okay, so the name of the game today is all about substitution. So we're going to go ahead and substitute the value that they give us to see if it satisfies or makes the equation true. Okay, that's it. So go ahead and make sure all your questions are answered. I do know when you don't watch the whole video, so I know if you watch the whole video. Get it? So, that's it. Answer all the questions, and then you can have a wonderful day. As always, email me with any questions or concerns or anything at all. Have a great day, and as always, be safe out there.